Hey everyone, we're going to look at number 3 in my practice homework, the definition of the derivative homework. Number 3 is a graphical example of interpreting the derivative. You're given the graph of the function h. This is this function. It's consisting of linear piecewise functions. You don't have to come up with the formula for these linear functions. You could do that, but you're not going to do that. Just to give the value of the following derivatives, we're simply going to find the slope, right? If it's defined on the point of the graph. And because this graph has line segments, we're going to be able to easily estimate that. So let's start with h prime of -4. Right, at -4, the value of the function, of course, is 0. So h of -4 is 0. There's the point. But remember, this is the derivative, and so the derivative is the slope of the tangent line. And the tangent line would coincide with this line segment. So the question is, when we ask what is h prime of -4, what's the slope? What's the derivative at -4? What's the slope at -4? Is simply the slope of this line. Can you determine the slope of this line? It's pretty easy. Remember, slope is the vertical change over the horizontal change, the rise over the run. And if I'm looking at two nice points, we have our point. If I look down here at this point, which is on the line, going from this point to this point, how much vertically do I go? I go up 1, 2, 3. Horizontally, how far do I go? +1, right, to the right one. Up 1, 2, 3 over 1, right? What's that slope? Vertical change divided by horizontal change. +3 vertical change divided by horizontal change, +1. 3 divided by 1. Slope is 3, right? That you should be able to find the slope of a line, right? So the slope of this is 3, and therefore the derivative at -4 is 3. What's the derivative at -2? Okay, -2. There's the point. The value of the function at -2 is +1, but the slope is the slope of this line, because that's the tangent line will coincide with this line. Okay, so what's the slope of this line? Well, clearly notice the line is decreasing, so I know right away the slope is negative. In fact, if I go from this point on the line to this point, I go down 1, 2 vertical units over 1, down 1, 2 over 1. So the slope is -2 divided by 1, which is -2. You might go from this point all the way down to this point. You could do that too, going down 1, 2, 3, 4, -4. Horizontal change though is 1, 2, right? So -4 divided by 2 is still -2. And so the slope at that point is -2, and therefore the derivative at -2 is -2. All right, what about at 0? What's the derivative at 0? Well, at 0, the value of the function is -1. Well, now we're talking about the derivative being the slope of this line, right? This is now the tangent line. And what is the slope of this line? Well, this line is horizontal. As I move from left to right, the vertical change is 0, and therefore any vertical change or the vertical change of 0 divided by any horizontal change is going to be 0, right? The slope of any horizontal line is 0. So the derivative is 0. What about at 2? Well, now we're talking about the slope of this line, right? Because there's the point. Output to the function at 2 is about -1/2. But what's the slope? What's the slope? Well, going from this point to this point along the line, I go up 1 vertically, +1, divided by 1, 2 horizontal, 1 divided by 2. Slope is 1/2. So I'm going to write 1/2 or 0.5. And then the derivative at 4, well, now we're talking about this line slope, and this line we go down 1 over 1, down 1 over 1. The slope is -1. Okay, there's the derivative of each of those points. Now, let me ask you this. This is not on here, but what would the derivative be if at, say, -3? What would happen there? What's the derivative at -3 if I ask for that? Well, at -3, notice we're at this sharp turning point. What happens at a sharp turning point? Well, the derivative does not exist. Function's not differentiable. And the reason being is as we approach from the left, from below, the slope is always what? 3, 3, 3, right? I said the derivative h prime at -4 is 3, but h prime of 4.2 is 3. H prime of -4.2 is 3. H prime of sorry, well, negative 4.2. H prime of negative 3.8 is 3. H prime of negative 3.5 is 3. H prime of negative 3.1 is 3, and so on. It's always 3. For any value of x between -5 and -3, the slope is always positive 3. But for any value between -3 and -1, the slope is always what? -2, back to -2. So the derivative from the left is positive 3. The derivative from the right is -2, and therefore the derivative does not exist at -3. And that's true, right? Functions are not differentiable at sharp turning points. So I would say the derivative would simply does not exist, or it's not differentiable. Okay. And so it's not differentiable at -3, also at -1, also at +1, and also at 3. So that's important. Okay, so I hope this helps explain number 3.